So of course there was no date written in there either. So when you make an entry, I told you to write down the date when the lab was done with the title, but that was missing, right? The rationale, if you look at it, today I will make chocolate chip cookies to decide how chocolate chip impacts baking. Okay, so is that good enough rationale statement? Okay, how chocolate chips impact baking. So very vague, right? So write down your critique if you want to. So methods, look at it and see if it's detailed enough, if you can repeat this by reading this. And the result, so look at this. This is a correction that's made, I guess. What did I say about making a correction? Is this the right way? You comment on that? Okay, so there's another entry. So if you want to maybe complete this documentation with your critique, so you can maybe upload it in the assignment section. I'll give you 5 pointed for this. And if you go back to your course shell, not only there's that lab notebook packet, there's another one, I guess. Let's take a look at it. So maybe there's a lab safety packet. Yeah, so between lab safety packet and lab notebook packet, I want you to choose one of them and upload as a lab 1 packet exercise, and whichever you upload with your answers, I will give you 5 points for that. Okay, that's one of the lab assignments. Okay, so that's that. And then let's talk about lab measurements. So when you carry out the experiment, okay, so you have to carry out your experiment, the task, very detailed. Otherwise, you cannot test your question because there may be so many variables in your experiment, right? So to eliminate all possible variables, you have to carry out very accurate experiment. So the accuracy comes from very accurate measurement of all the chemicals and all the things that you use in your experiment, right? So the lab measurement is very important. So then when I say lab measurement, what kind of measurement are we talking about? Let's say you're asked to make a solution of maybe made out of tris base, a buffer. And the solution should be made as a 1 molar concentration. Then when you're asked to measure out 1 molar, what does that mean in terms of how many grams of tris salt in water, right? You need to understand that. Okay, so the mole concept in chemistry, you may know that a certain weight of that chemical will give you certain molar number of that chemical. Okay, so yeah, you need to know the molecular weight of the chemical to be able to measure that. So normally it's a 1 molar given chemical weight per liter is defined. So you should be able to know that and calculate out to be able to carry out that. So in that task, so you need to measure the amount of chemical, the weight. Okay, then how do you measure that? What is the instrument that will allow you to measure that weight? It's normally the balance. Then you need to know how to use a balance. Okay, so then when you use a balance, so what are the variabilities? You should be able to eliminate all the variabilities in your measurement. Okay, so you need to know how to measure the weight accurately. So what is the unit you're going to be using when you do the weight measurement? Are you using maybe pounds? Are you using in gram? Which one is it? So normally we follow international unit. Okay, international unit uses metric system, okay, which is in maybe grams, which is maybe meters and centimeters and liters. Okay, so that's a metric system, which is different than what the people in the United States are using. So the US system is imperial system, which is unique. So unfortunately in science it's metric system, so you have to get familiar yourself to the metric system. Okay, so there's a metric conversion practice batch record in your course shell. Again, I want you to go back and maybe there's a metrics practice batch record there. So I want you to download maybe take a look at it and see if you can solve those questions. Let's see if I can show you what that is. So this is it. So that's batch record. So batch record form, it looks like there's table of content, sections, and sections with blanks. It is you who is the preparer. If you have a lab partner, the lab partner will be a verifier, initial date, and probably I will be the additional verifier if you will want to turn that in for your credit. So volume practice, like I said, in metrics, the volume units are liter, milliliter, microliter, right? So the conversion is it's kind of thousandfold. So normally like 100 milliliter equals what? 0.1 liter, because 1 liter equals 1000 milliliter. Okay, so if you convert 100 milliliter into liter, it's going to be 0.1 liter, right? And if we go the other way around, 2.4 liter, so liter is thousandfold of milliliter, so 2.4 times 1000, which will be about 2400 milliliter, right? Same way between micro and milliliter, so 1 milliliter equals 1000 microliter, so you can convert that. So 1292 microliter will be same as 1.292 milliliter. Okay, 54 milliliter, you have to multiply 1000 if you want to convert that to microliter. Okay, so these are our practices. Again, 9496 microliter into a liter. Now it's not milliliter, it's a liter. So 1 liter equals 1 million microliter. So it's the other way around. So you have to divide 9496 by 1 million. That's going to be the liter. Okay, and the mass practice, it's a weight. Okay, in measuring weight, there's a kilogram, gram, milligram quantity at the units. Okay, 1 kilogram equals 1000 gram, and then 1 gram equals 1000 milligram. Understand that? Then you will be able to convert this. So it's the practice. You can do this and submit it. So I guess there are 3 options you can choose from. So choose one for 5-point credit. Okay. Terms in measurements. So when you measure something, okay, you may have to use something called a standard. So think about you are doing a weight measurement. Okay, how do you know the balance you are using is really accurate, doing its job or not? Okay, so you place your object on that balance. The balance reads it's 1.5 kilogram. How do you know if your balance is really accurate? So what it's reading, 1.5 kilogram, is really 1.5 kilogram or not? Okay, if you want to test that, you want to use something called a standard. Okay, standard is a physical object that embodies the unit. Meaning, what if you have a perfect weight standard? It says it is 500 grams. Okay, then when you place the standard on your balance should read it as 500 gram. If it doesn't, instead it's reading it as 700 gram, that means there's a problem in your balance. Your balance is not accurate, right? So standard is needed to calibrate your instrument. So calibration means what? Adjusting measuring system to value that are accordance with the standard. So if the standard says 500 gram, your balance should say read it as 500 gram. If it doesn't, you have to calibrate your balance to make it read your 500 gram standard as 500 gram. Okay, understand the importance of standard and calibration? Okay. Okay, and the weight measurement, we already talked about it. So weight is defined as the force of gravity that is applied on an object. So that is measured on the balance. And that has a little different definition than mass. Mass is amount of matter in an object, which is different. So mass is more absolute than weight. Weight is different. It varies based on the gravity of your planet. Anyway, so the balance is the unit, the instrument you're going to use to determine the weight. There are electronic balances, mechanical balances, but normally these days everyone uses electronic balances. You should know how to use electronic balances. I'll show you in the lab. And the unit in measurement, measuring weight, of course I told you 1 kilogram equals 1000 gram. It's always thousandfold. And then 1 gram equals 1000 milligram. And if you can measure microgram, which is not possible using our balances in the lab, but just understand the conversion factor. 1 milligram will be same as 1000 microgram, and 1 microgram equals 1000 nanograms. So normally in the lab you will be dealing with maybe kilogram, gram, and maybe milligram quantity, and micro and nanogram you will not be able to determine in the lab because we don't have the instrument for those. Okay, and then volumetric measurements. So volume is defined as amount of space a substance occupies. Okay, so normally it's a liquid form that you measure as in volume. So what are the volumetric devices that you can use in your volumetric measurements? So things like graduated cylinders, burettes, pipettes, micropipettes. Those are the main things that you can use. And you may wonder, how about beakers and flasks? You may be able to see some graduation on the side of beakers and flasks. Although you see those graduation, but you don't use beakers and flasks to determine accurate volumes because they have too much error. Those graduations not trustworthy. So normally beakers and flasks are not considered as volumetric devices. Okay? And the unit of volumetric measurement is normally in metrics, it's a liter, milliliter, microliter. So 1 liter equals 1000 milliliter, 1 milliliter equals 1000 microliter. So understand the conversion factor. Okay? And you can measure a microliter range of volume using a special device called micropipettes. So you'll be dealing with micropipettes a lot in the lab because you will be using very small amount of liquid, maybe enzymes and substrates in this class. So you will get used to micropipettes and how you use them. Okay, so micropipettes are volumetric device that can determine the volume in very small quantities. That small quantity is normally from 1 to 1000 microliter quantity. So again, 1000 microliter equals what? 1 milliliter. So maximum is 1 mil, and it can get lower, less than 1 microliter. You can determine using micropipettes. And when you use a micropipette, you have to use a disposable tip that's placed at the end of the pipette barrel. Okay, so micropipette tip is making direct contact with the solution, not the pipette itself. How to use a micropipette? You have to follow this process. First, you have to choose an appropriate micropipette because there are several different kinds, and each micropipette will have defined range that it can cover when it's used for measurement. Okay, understand the range of micropipette and choose the correct one. That's the number one. Once you have chosen a micropipette, you need to set up the defined volume on that micropipetter. So there's a normally rotating knob. It's found on the head part of the micropipetter. When you rotate, you will see the change of the displayed number on your micropipette. So normally the displayed number is the unit, volume unit your micropipette will be set up at. Okay, so rotate maybe back and forth and see how the numbers are being changed. Once your volume is set up, then you're going to place a tip, disposable tip, at the end of the micropipette barrel aseptically, meaning without getting contaminated. So there is going to be a box of micropipette tips in the lab. You open the lid of the box quickly and insert a tip on the barrel of the micropipette by firmly pressing it and get the tip away from the micropipette tip box, and you will see that the tip is attached to the barrel. That's how you can make an attachment of the micropipette tip. And then once that's done, you have to press the plunger button to the first stop, and then you have to keep your finger onto the spot by continuously pressing the plunger button. Okay, but at this point you need to be careful. You don't want to press the button below that first resistance stop point, because if you press it further, yeah, the plunger will go down, but you're exceeding the volume that you are set at. Okay, so you need to practice a few times by placing your thumb on the button and press it and feel that first resisting point, and hold your thumb there. Okay, and release it slowly. Press it and feel the first resistance point and hold it. Okay, so that's what it's talking about. So when you press it, that means there's a spring inside of pipette. It's being pressed. Okay, and when it's pressed, okay, and then if you release it, the vacuum suction will take place at the tip. It's going to draw in the liquid. Okay, so that's important to understand. Okay.